Okay, hello, I'm Cole Hughes.
I'm Melissa Geringer.
And for our experiment, we decided to test the Madagascar hissing cockroach's ability to correct itself when flipped over onto its back. Okay, so there can be many times in the wild where a Madagascar hissing cockroach ends up on its back struggling to correct itself. This can be from just slipping off of a wet, slippery leaf, or from one of his buddies knocking him over, flipping him over because they do live in condensed hives or colonies. Anyway, being flipped over is dangerous for them because of how vulnerable they are in this position. Not only is the vulnerable underbelly exposed to danger, the Madagascar hissing cockroach is also immobile and unable to flee from a potential predator stuck in this position. It is absolutely pertinent for the roach to be able to correct itself and get back to its feet in a timely manner to escape the threat. So we decided to base our experiment based on this aspect. We replicated two different surfaces, one smooth, one rough, and timed how long it would take for the Madagascar hissing cockroaches to complete each. So our main objective is to determine how fast can the Madagascar hissing cockroach correct itself on different surfaces. Our hypothesis is if flipped and placed on a rough surface, then the Madagascar hissing cockroach will be more successful correcting itself in a shorter amount of time. We chose this hypothesis because it's general for any animals that when walking on a rougher surface with more texture, it's much easier to walk than on a smooth surface.
So a little bit of background info on the Madagascar hissing cockroaches. They actually live on an island called Madagascar, and they live in large colonies. The males are often bigger than the females, and they sport large horns, which are used for fighting other males to establish dominance. They approximately live up to 18 months and are around 2 to 3.5 inches long. And there are small areas of flexibility throughout their bodies and legs that allow for mobility. This can potentially help. It can potentially help when the Madagascar hissing cockroach falls on its back and it tries to upright itself. The Madagascar hissing cockroach also has specialized legs, such as the tibia and tarsus, and pads on their feet called tarsal pads. These allow for mobility along many different types of structures and surfaces, such as the smooth and the rough surfaces. The flexibility of the exoskeleton, combined with the functionality of the legs, is what gives the roach the needed mobility to correct itself. So our experimental variable for this procedure was the rough and smooth surfaces. We would just switch out which surface the Madagascar hissing cockroach was put on for different trials. Our controlled variable was just how long it took for the cockroach to flip itself over. Over the duration of the semester, my partner and I recorded the time it took for different cockroaches to flip on both a smooth and rough surface, and then we compared the differences between the times. We chose turf as our rough surface and a countertop as our smooth surface. We placed the Madagascar hissing cockroach onto its back and recorded the time it took for it to correct itself. We performed this 3 times, or 3 separate times on each surface. And then we wrote down the data. And we did this a total of 3 solid times for 3 different experiments. So as you can see on the screen, we have our quantitative data for our first experiment and our first trial. For our first experiment and first trial, it took 2.18 seconds for the cockroach to correct itself on a smooth surface and 2.28 seconds to correct itself on a rough surface. For the second trial, it took 6.85 seconds to correct itself on a smooth surface and 2 seconds to correct itself on a rough surface. And for the third trial, it took 3.8 seconds for it to correct itself on the smooth surface and 1.5 seconds to correct itself on the rough surface.
Okay, also the average time for the smooth surface on experiment 1 was 4.2. The average time for the rough surface for the experiment 1 is 1.9 seconds. Moving on to experiment 2, in the first trial, it took 2.29 seconds for the roach to correct itself on the smooth surface and 2.16 to correct on the rough surface. Trial 2, 1.94 seconds to correct on the smooth surface and 2.3 seconds to correct on the rough surface. And for the third trial, it was 3.77 seconds for the smooth surface and 2.38 for the rough surface. And the average times for the smooth surface overall were 2.6 seconds, and the average time for the rough surface overall, 2.25 seconds.
For the third and final experiment in our first trial, it took 4.58 seconds on the smooth surface and 1.63 seconds on the rough surface. For the second trial, it took 1.84 seconds on the smooth surface and 0.89 seconds on the rough surface. And for the third trial, it took 1.35 seconds on the smooth surface and 1.02 seconds on the rough surface. The average time for the smooth surface overall was 3 seconds, and the average time for the rough surface overall was 1.18 seconds. We do think that it is relative to mention that it was our original intention to use the same Madagascar hissing cockroach for each one of these experiments, but due to COVID-19 and unforeseen complications, we were unable to do so.
Also, based on this data, we're able to tell that smooth surface takes much longer on average than the rough surface. Okay, moving to the t-test. Here are our results for the t-test. I'll just read it. Treatment 1 on the smooth surface, the mean was 3.15 and degrees of freedom was 8. On treatment 2, which was the rough surface, the mean was 1.78 and the degrees of freedom was 8. The t-value, 2.24292, and the p-value 0.019707.
And then we have a graph here just pretty much summing up all of our data. As you can see, it's very clear that it took much longer for the cockroach to correct itself on the smooth surface compared to the rough surface, which therefore concludes that our hypothesis was correct.
So in the end, we were able to prove our hypothesis to be true. The Madagascar hissing cockroach has a much more successful correcting itself when placed on a rough surface rather than a smooth one. So implications. The Madagascar hissing cockroach is able to grip much faster on rough surfaces. This implies that the Madagascar hissing cockroach is biologically more suited to live in habitats which contain rough surfaces such as like dead leaves and grass and dirt, rather than the smooth surfaces like glass and plastic, which are often being used in captivity or to transfer them, as we saw in our classroom. They had a hard time gripping to those. Mm-hmm. And while we are satisfied with the results, we still think it could, if we could have used the same cockroach, it would have been much better for our experiment. Our data would have been more accurate and just more conclusive. But regardless of that, it's no one's fault that we couldn't. It's okay. Regardless of the complications, we're still successfully able to prove that our hypothesis was true, thus making it a successful experiment. And here is our works cited. So yeah, Madagascar hissing cockroaches can easily flip over on the rough surface, just like our hypothesis said. Okay, thank you. I'm Cole.
Melissa.